in lecture 4, we're going to start to learn more about Python programming basics on functions and modules. And these are things that you will be using in your future programming. So as a review of the last lecture, and we have learned one more data structure called dictionaries, and which comes up with a key and value pair. And relational and logical operations, basic Python program structures, including code blocks and indentations, and pay attention to indentations because that's the only way we identify code blocks in Python. And also program control with if and if-else statements. And we also learned a while loop and how to write a for loop. These are very useful basic program control syntax that you will be using a lot in the future. And also the last one, we learned a slightly more complicated loop called nested loops, which is a for loop with embedded if loop in it. Right, so in lecture 4, we will learn more about functions and modules, and including how to define and call a function, and also how to use or define a module in Python. So what are functions in Python? So the functions are basically a bunch of Python codes that are reused in complicated programs. So basically these are small pieces of codes that can be used again and again in the code whenever you do the same thing. For example, think about this. You have, I want to calculate all your final grades based on all your homework grades and exams, right? So I have a bunch of numbers to add together and times their percentage. So I will do that multiply and addition for everybody, right? So I get a number for every person. So for example, I have 10 students, right? So I can do it 10 times. But what if I have 1,000 students, right? So I need to save my calculation to get everybody's grade using a formula as a function. Then I just call that function 1,000 times without writing that function 1,000 times myself. So this is called reuse of Python codes, which are basically functions. So why we need functions? Because functions make your code very efficient. For example, you don't need to rewrite your code 1,000 times. You just call the same thing 1,000 times, right? So every time we see the function name and we know what you're trying to do, they're readable and reusable. And how to create functions in Python? So we use the def statement and also the return, which is optional. We'll talk about that later. So the def statement, so def, that's a reserved word in Python. So you're not supposed to use that for a variable. So it's def statement is used to define functions. And here's a simple example of creating or defining a Python function. So don't worry if you don't understand the details, but the basic idea here is that you start with the def, which tells Python that I'm going to define a function. So with a function name called convert f to c, and parenthesis in arguments, input arguments here, and pay attention to the column, and don't forget that. And have the triple quotes here with strings here to describe what this code does or what this function do. Right. So you can see that these red, remember that triple quotes are also used for strings. Right, so this is a very long string describes what this function do. And here, this line of code is basically what the function actually do for the calculations, which here is apparently this converts anything that you give to the function from Fahrenheit to Celsius, right? So return the output, right? We'll talk about that later. Right, so how to call the function in your Python? So once this function is defined, I want to reuse it, just type in the function name and with appropriate input arguments. For example, I want to convert 100 degrees Fahrenheit to Celsius. What I do is in Python, I type in convert f to c, parenthesis, 100. So if you do that, and 100 is going to pass into this function and going to go through this calculation and give you the output argument, which is going to be 30.7 degrees, which is basically 100 degrees in Fahrenheit. All right, now let's go through how the code works as the function you saw in last slide. So here we have the definition of the function and the string here and function body and return something. And after the function is defined, and let's call the function here by simply typing the function name with input value. All right, so in line 1, if you look at this, and def convert f to c in arguments, that's the first line which defines a function. So this line tells Python that we're defining a function called convert f to c, right? So in args here, basically input arguments. So you can specify whatever input arguments you want here and can have many of them. And pay attention to that. You need to have the column here to stop it, right? Otherwise, you get an error says the function is, there's type error or something else. All right, so in line 2 to 7 are separated by these triple quotes, and which means that these are strings. And also these triple quotes called docstring for a function. They're basically comments for a function, but they just called docstring. So the docstring is a description of what the function does, and that can be accessed later by using the help function, right? So if you type in the help function, and the docstring will show up. And basically, this is basically comment for any function you do. So this is my style, and I would recommend you do something like this to tell people what this function does, and what's the input, what's the output, and what's the algorithm. So you know exactly what your functions are doing. So the next line, which is line 8 here, and we look at that in line 8, we have a mathematical operation. Here is out arguments equals in args minus 32 divided by 9 times 5, which converts Fahrenheit to Celsius and give this number to a variable called out arguments, out args, right? So the function body of this convert f to c is basically line 8, so that's all. And the first calculates the temperature using the input variables and convert to Celsius, and then we assign the variable to the another variable to out args. So return variable, the return statement here is something new here, but so what it does is that the return the results whatever the function did. So here it returns the value of the temperature in Celsius, which is stored in the variable called out args. That's why you get an output when you call the function here, right? So line 12, that's where we call the function. So we type in the function name, and we want to convert 100 degrees Fahrenheit to Celsius, and we type in that. And then now because we have a return statement here, and then in the screen, Python will tell you it's 37.7, as you've seen from the last slide. So the difference here is that if you don't have the return statement here, the calculations are done inside the function, but there's nothing assigned to this calculation, so you get nothing. So if you don't have the return, there's nothing to be returned, and it's just you run the function and you get nothing. All right, so a couple of tips on how to define a function comes with, first, how do you write the docstring? So the docstring briefly describes what the code does. And for example, usually, you wrote the code, you wrote an awesome code, and after several weeks, you totally forget about what you did. This happens to me all the time. All right, so that's why you keep the docstring as the first part of the function. Then you can help yourself or others to know what your program does, what your function does. This is very important. I think it's a part of something like comments, and you should be doing it all the time whenever you do functions. And also if you type in the help function, use the help function, and it will print out the docstring for your function. For example, use the function that we just defined, convert f to c, and we type in help, convert f to c, and then on the string, and you get exactly what you put in. And the docstring tells you this code convert Fahrenheit to Celsius, and input is a temperature in F, output is temperature in C, and algorithm goes something like that, which is very neat. So the function body, when you define the function, to pay attention that your code must be indented, and indentation is the key of the Python code structure. So everything is differentiated by indentation, right? So just like a for loop, or you can just regard the function body as a block of Python code under a def statement. So pay attention to the indentation. And also the return statement, as we just explained, and you can either use it or not use it. So Python separates the input and output arguments. So incoming arguments are passed through the def statement, and the returning arguments get shipped out with the return statement. So if you don't have a return statement, everything in the function body is going to be executed, but there's nothing shipped back to the screen, right? So if you don't return anything, and there's not gonna be output directly. So another couple of tips are basic on the scope of variables, which are called either local variables or global variables, right? So inside a function, variable names have their own meaning, which in many cases will be different from outside the calling function. In other words, variable name is declared inside a function, stays in the function, and cannot be accessed outside the function. So let's take a look at an example. So I define a function called Las Vegas, and this is a doc string. So what this function do is that whenever I call the function, I assign a value, a string called casinos, to a variable v, and I do return in this case, but I don't return anything, right? So and in this code, and if I do, after I called the function Las Vegas here, and I print out v, because you would say, oh, I defined v here, which equals to casino. Then if you run the code, and what you get is name error, and what's telling you that name v is not defined. Why is that? Right? So you can see that this is the code block in the function. So v is defined inside the function. Whenever the function is called, and v is defined, which equals to casino. So after the function is done, and everything you defined in the function disappears. So there's no v in the memory, and then when you're trying to print out v, Python tells you that, well, v is not defined, right? So this is called a local variable. So the variable v is a local variable, only lives inside the function Las Vegas. Outside function, there's no v, right? So let's take a look at example if you want to access a variable inside the function when it's called or it's outside the function, right? So here, what you do is that you define the variable as global, right? So for example, we define function San Diego, and we have another line of code called global g. So now g is a variable, but it's a global variable, means that g lives inside San Diego and also outside San Diego. So now let's assign the value to g, which means g equals to surfing. That's a string, and then we return, right? So now I called code San Diego, and when you call this, and g is created and assigned as a string variable named is surfing, right? So then I print g, and you got surfing. In this case, g is called a global variable, which means it's not only valid inside the function, it's also accessible outside function. So unless you want your variables to be accessed outside your function, you use the global syntax to do that. Otherwise, everything is local. Now let's pay more attention to how do you pass arguments to functions. So pass arguments to functions, basically you give input values to a function for calculations, right? So the most basic way to pass arguments to function is pass fixed amount of arguments. For example, in this function name with arg1, arg2, arg3, and whatever you defined, and how many you just pass exact the same amount of arguments to the function as it's defined. For example, let's take a look at this function called degree to rad. So we convert degrees to radians. So input argument is defined as 1, so it's degrees. So it takes one value, which is in degrees, and convert it to radians, which is simply times pi divided by 180, right? So now let's use the function with input equals 40 degrees. So we print out 42 degrees in radians we call the degree to rad function and convert 40. So this code first evaluate degree, the red 40, and then return the value in radians, and then print out as a string, right? So if you look at the results, it tells you 42 degrees in radians is about 0.69 radians in this case. All right, so you can also pass arguments with default values specified using the equal sign, which means that if I give an initial value to my input, and you can use that as a default value, right? For example, let's take a look at this function. It's called ask OK. So def ask OK, and retries equals to 2. So pay attention to this syntax. So which means that if I don't give any input arguments with retries, it's going to use 2. And the second argument is called reminder, and its default value is set to be please try it again. So if you don't give any reminder as a second argument and the input argument, and then it's going to use please try it again as a default. Right, so what this code does is that the code body does while true. Remember, while loop, if it's true, this gets executed, right? So while true and OK equals to input, please enter yes or no. So the input function will create a box in the Jupyter notebook, and then you can put in your answer string to it, right? So you put in a string to it. All right, so if OK is one of these, y, yu, yes, yup, and then we return true. Otherwise, if it's not, if it's in n, no, or nope, and then we return false. And retry equals to retry minus 1, and then you tried once and you could try it again, right? So when this is done, and then now retry is less than 1. So if we check whether retries is less than 0, and we print out too many retries, invalid user response, exiting, which means that that's just a print statement, and then we return. So this return statement is only executed when retries is less than 0. So when it's returned, and then the execution is going to jump out of the function loop and move to the next one, right? So let's try call the function ask OK without any arguments, right? For example, remember that we have already defined default values, right? So I call the function just by typing the name, called ask underscore OK, and parentheses without any inputs. But remember that we have already defined default values for this function. So retries will be equals to 2, and reminder will be equals to please try it again. All right, so what happens here is that it's gonna first print out this please enter yes or no. So I typed in yes, and then because I typed in yes and OK is in this yes tuple, this is a tuple in this, so the function is gonna return true, right? And then it's gonna return. So once it sees the return statement, it jumps out of the function, and the function call is done, right? So there's other ways to pass arguments to functions, and you can either pass a variable amount of arguments called variadic functions, which start with a star. So function name star arguments, or you can also pass a key value pairs by doing function name with double star arguments. So these two methods are more advanced uses of Python programming, which we will not be using in our basic programming skills. So I'm not going to spend too much time on it, but if you're interested in how to pass arguments to functions to do more advanced programming, and you're welcome to check out this page on the Python tutorial page and see if you can find more information there as well. All right, so when you defined functions and how we put everything together, and now let's take a look at the main program. So this is basically a place that you put everything together, right? So it's usually considered as a good Python style to treat your main program as a function as well. So this helps with using the docstring as a help function and building good program documents for a large project. So you always have a main program does everything, and then you explain what you did in the main program. Right, so this is an example of how you defined and use a main program. So now I have three functions defined. I'll use the def statement. So I define the first function is degree to rad, and we do convert degrees to radians. And the second one, I define a function called convert F to C, which converts Fahrenheit to Celsius and does everything. And now I define a third function. Now the function name is very specific. It's called the main parenthesis. So in the main function is basically the code block that does everything I want, including using the two functions I defined above here, right? So in the main function, I first defined a variable called my degree, which is 75, and my Fahrenheit to 75, right? So the next code block, I call the function degree to rad, convert my degree to my radians, and also I call the next function, which converts F to C of my Fahrenheit to a new variable called my Celsius, right? So after I call the two functions, I print the results out using the print statement, and you're quite familiar with how to use this kind of print statement. All right, so this main function does three things: define variables, call the functions, and print out the results, right? In this case, so now let's run the main program. It's really easy to do. What you do is to type in main parenthesis. So there's no input argument. So this is basically a line, a function does everything that I want to do with the other functions, right? So if you look at the output, what the main function does is that everything gets executed, and you got two outputs called my degree. 75 degree is in radians is 1.3, and 75 Fahrenheit in Celsius is 23.8, right? So this is how we put everything together, use a main function. Now you've learned functions in Python, and let's take a look at another important concept called modules in Python. So what are modules in Python? So modules in Python are collections of functions that can be reused in any Python code. So modules are a bunch of functions, right? So why we need modules? Because they're efficient and make your function reusable, or save your time by using other people's modules. For example, in nowadays, whenever you want to do something and you use other people, you always go look for a module that has been developed by someone else who does a specific amount of things, right? So how to create your own modules in Python, and this is going to be something we're going to try in this lecture, is very simple. Basically, you type in all your functions in a Python script with a suffix.py and save it in somewhere Python can access. And for example, today, you're going to create a Python module and save it in your working directory, so Python knows exactly where it is. So how to use modules in Python? Very simple. We use another reserved word in Python called import. So the import command can be used in multiple ways. For example, import module, which means I import something called module. Or you can import module as something else. So you import a module, but I want to name it something else, and then you get another name. And from module, import some submodule. So for example, I want only a part of the module. So from module, I import something, it's a subset of the module. The last one is from module import everything. So this is using a star, and we will see what does that do later, right? So modern data science in Python is all about modules. So what makes Python so powerful is because of the modules, right? So the idea is that because it's open sourced, right? So lots of people are working on Python for data science, and whatever you're trying to do, and people probably have already developed something to do it, right? So that's what makes Python so powerful, because you can always use a module that's developed by someone else to do the job that you want to do, right? So that's a nice thing about open source softwares as well, right? So how to create a module in Jupyter Notebook, which is relatively straightforward. And step one, open the Jupyter dashboard by clicking the Jupyter symbol in Anaconda. So so you got a dashboard. All right, so the next step is to create a text file by clicking New down here on the upper right side, and in this menu choose text file. Right, so after that you get into a new text file called untitled.txt. So what you do next is you type in all your functions in the text file. Pay attention to the syntax, right? So pay attention to indentation here. So now in this module I typed in 3 functions. All right, so next, the last step is to rename the file to have a suffix with .py, and I change it myfuncs.py, and by clicking the title and rename it and save it in the same directory that you're working with, so Python knows exactly where it is, right? So after this is created, so now I have created a module called myfunctions, which has 3 functions included. Now I can call these 3 functions from this module. All right, so how are we going to do it? Now we have created the first module called myfuncs.py. So to use that, remember that we use the import command, right? So the import command, it goes like this: import myfunctions, myfuncs. So this tells Python that I want to use this module. So Python, go to your directory, find out this module, and load all the functions and to it, and it knows where to look for those functions, right? So how to use those functions here? So what I do is pay attention to the dot operator. Is that if I want to call the function degree to red in myfuncs, what I do is myfuncs dot degree to red 45. So what this code does is Python is going to this module, you just load it or import it, and looking for a function called degree to red, and find that function, and then I'm using 45 as input. So I'm converting 45 degrees to radians. All right, so the same thing happens here as I'm converting 45 degrees Fahrenheit to Celsius, and also looking for the function in this module called myfuncs.convert F to C. Right, so that's the output. All right, so recall the help function can also be used to a module in Python. Is that here, if you type in help myfuncs, and what it does is that it gives you the module name and all the functions included in the module, including the doc streams, right? So look at that, the San Diego function that we did not have any doc streams in it, which is a bad practice. So you should always put in doc streams for a function. And you got the other functions called convert F to C, degree to red, and with explanations what that code does. And also it tells you where this module is, and this is where the directory where the function module is saved in my computer. Before you start to create your own modules, let's take a look at a couple of useful modules in Python. Right, for example, the standard modules there are lots of standard modules, and these are very frequently used modules in Python. Will be the OS, that's the name called OS, and provides functions for interacting with the operation system. And the sys module provides access to some variables used or maintained by the interpreter and to functions that interact strongly with the interpreter. Well, don't worry if you don't understand this, because we are not going to use this, because this is for more advanced Python programming, for system level programming, but we're not going to use this. So the math module, which is a very convenient one, provides access to mathematical functions defined by the C standard. For example, sine function, cosine function, logarithm, etc. And the datetime module is also a very useful one, which supplies classes for manipulating dates and time in both simple and complex ways. Like if you want to calculate the date and time and make your axis using date time, this is also a module to look at. So numerical analysis tools, we have the NumPy module, which is called Numerical Python, NumPy, and this is the fundamental package for scientific computing and analysis with Python. So this is one of the most important module that you need to learn in order to become, at least a good user of Python. And the other one is called SciPy, but this one's more specific. It's actually scientific Python. So this is a collection of numerical algorithms and domain-specific toolboxes, including signal processing or time series analysis, we will see later, optimization, statistics, and much, much more, including things like special functions. And the other one is data handling module, which is the Pandas, right? So Pandas is an open source library providing high performance, easy to use data structures and data analysis tools for Python programming. Pandas is very, very, very powerful on data handling, including how you sort the data, clean the data, and make the data ready to use. So this is going to be the second important module that you need to learn later on in the course for Python. So the last one is visualization, right? Because you got the data analyzed, but you need to show people the results, and that's called visualization. We usually use 2D or 3D plots. So Matplotlib is a module that provides popular plotting tools and give you publication-ready 2D and 3D plotting, and we will use Matplotlib a lot. Right? For some of you might be familiar with MATLAB, and basically NumPy plus SciPy plus Matplotlib basically gives you MATLAB, right? For data scientists, these are the toolkits that you need to learn: NumPy, Pandas, and Matplotlib. All right, so for example, let's take a look at how to use a module called Math, which is a built-in module, default standard module from the Python programming, right? So if you remember that to load the Math module, use import math. So import plus the name of the module, right? So to access data in the Math module, because the module comes up with functions and also data, right? So in this Math module, there are a couple of constants called the pi and also the Euler's number and tau of these numbers, but you use the dot operator, right? So math.pi means that I'm trying to access a variable or constant named pi in the Math module, right? And then Python will give you what pi is in the Math module. If I want to call functions in the Math module, remember that we got math.cosine, math.log, right? So for example, let's take a look at this code. Import math in this way. So I'm going to print math.pi, which give me the value of pi, and print math.cosine pi over 5, which means I'm using a function in math, which is called cosine, and I'm evaluating what's the value of cosine pi over 5. And the same idea as the logarithm function is 1024 to the logarithm with base of 2, right? So the result is 10. So you can also rename your Math module. For example, use import math as MT, right? So why do I did this? Because I think math is 2 letters to type. That's too many, right? So I want to save it. I call it MT. So once you do that, if you did that, and when you call these constants or data or functions, it will be mt.pi, mt.cosine, mt.log. So whatever nickname you give it here, you just use that nickname to access the functions inside that module. Or if you don't want to use a prefix for the functions, for example, you're too lazy to use the math dot syntax, and you can do from math import star, which means that I'm ignoring the name of the module. I'm just gonna use the functions, right? So if you do that, from math import star, and there's no prefix, and now all the functions in the math you can access directly without the name of the module. For example, you can do pi, cosine, and log. Looks quite convenient, right? But this is not usually a good practice because Python has so many modules, and some of the modules may be using exactly the same name of the functions, right? So if you do this for all the modules and then you're confusing, you might be confusing yourself in some cases that where is this function coming from? Are they coming from the same modules? Are they coming from different modules? So the best way is always to give the module a name so you know where that function is coming from. But this is also an option you can do for very simple, coding.